There are basically two types of nuclear weapons in the conventional sense. Ones which run off of only fission, and weapons which run off of both fission and fusion. The first nuclear weapons were powered by nuclear fission. These are usually referred to as atomic bombs or A-bombs. These bombs function by pushing uranium or plutonium into a state of supercritical mass. This means nuclear reaction which will increase in exponential rate. In fusion weapons, or thermonuclear weapons, a single fission reaction acts as a sort of catalyst to begin a fusion reaction between isotopes of elements such as hydrogen. Unlike a fission-based weapon, these reactions may continue to occur with no essential limit. These reactions cause explosions of fusion fuel, which cause radiation and high-yield detonation. The largest ever thermonuclear detonation was the Tsar bomb, tested by the Soviet Union. It had the equivalent of 50 megatons of TNT, or 50 million tons. Delivery is a major variable in the type of bomb used, and the resulting scope of devastation. The first nuclear weapons were deployed from bombers and relied only on gravity to deliver them. This allowed for larger bombs until suitable methods of creating smaller but still effective weapons were invented. Throughout the Cold War, many other methods of delivery were invented. The MIRV, or MIRV, is particularly devastating. It has many warheads, which are all directed at different targets, and thus it is very unpredictable. Submarine ballistic missiles and intercontinental ballistic missiles also allow nations to launch strategic nuclear strikes from almost anywhere in the world. It is very difficult to predict how far the radiation from a nuclear detonation will travel. This depends on atmospheric conditions and the size of the weapon. However, blast radiuses are more easily predicted as they are simply calculated from the equivalent amount of TNT in the explosion. For instance, take a 30 kiloton nuclear weapon, which is pretty average. The blast radius is about 0.8 miles. However, this does not factor in the resulting heat wave, which could kill anyone up to about 2 miles after the initial blast, which is a very scary thought.